Okay, so there's another way that we can use Q equals mcat. So if we have a question like this, if we have 100 grams of an unknown metal at 23 degrees Celsius and 100 grams of water, or 100 milliliters of water, at 100 degrees Celsius, the temperature of the system is 80 degrees Celsius, so meaning the water and the metal, is 80 degrees Celsius after the metal is added to the water. What is the specific heat of the unknown metal? So, in this equation, again, we have water going from 100 degrees Celsius to 80 degrees Celsius, so we know that we're not changing phase. And we can pretty much assume that adding metal to water isn't going to cause the metal to change phase either. So we're going to use our Q equals mc delta T. But in this case, we have two different substances that we're working with, metal and a water, and we ultimately want to find the specific heat of our metal. So how are we going to do that? Well, we can try to plug all of our information in for our metal and see what we come up with. So our Q for our metal, so the M just denotes that this is the equation for metal. My Qm is going to equal my mass of my metal times my specific heat of my metal, which I'm trying to find, times my temperature change of my metal. So I don't know my Qm, but my mass of my metal is 100 grams, and the specific heat of my metal is what I'm trying to find, and my temperature change of my metal, remember it's final minus initial, is 80 degrees minus 23 degrees. Well, unfortunately, I have two variables. I have my Qm and my Cm, so this equation by itself isn't going to help me. Well, I still haven't used any of my water equations or any of my water variables and numbers, so let's see how far we get by using that part of the problem. So let's plug it in for my QW. So the W just denoting that this equation is going to deal with all of my information for my water. So my mass of my water is 100 grams. I know that the specific heat of my water is 4.18 joules per gram per degree Celsius. Again, that'll be given. And my temperature change is final minus initial, 80 minus 100. And notice here I'm going from a smaller number to a bigger number, so that my temperature change is going to be negative. So this is going to be QW equals 100 times 4.18 times negative 20. So my QW, or the heat that is going to be in this case released, that is going to be released by my water as it cools, is going to be 100 times 4.18 times negative 20. So I'm going to get a negative number. I'm going to get specifically negative 8,360 joules. So at this moment, this actually doesn't help me all that much. I'm going to make this a little bit smaller. So I still haven't found the specific heat of my metal. I found the Q of my water, but I still need to find the specific heat of my metal. Well, I know that when I mix two substances at different heats, the energy lost by one, or the heat lost by one substance, is going to be the energy gained by the other substance. So in this case, my metal is starting at a temperature of 23 degrees Celsius. And once I mix it with the water, its temperature raises to 80 degrees Celsius. Whereas my water actually started warmer. It started at 100 degrees Celsius, and it went down to 80 degrees Celsius as well. So my metal actually gained heat while my water lost heat. And the energy or the heat lost by my water equals the energy or the heat gained by my metal. So I can write that like this. QM equals negative QW. So now I have something to set this QM equal to. So now I just plug in my entire equations or my entire equation for QM, I plug that in for QM, and I plug this in for my QW. So my QM is 100 cm times 80 minus 23, which is 57, equals negative 8360. But remember, my QW is negative, so I actually have a double negative, which is going to make that positive. So then this is going to equal 5,700 times CM equals 8360. Now finally I can solve for my specific heat algebraically. So 8360 divided by 5,700 gives me a specific heat of my unknown metal of 1.466. I'll round up to 1.47 degrees Celsius. So if you have a question where you have two different substances at two different temperatures being mixed together, you need to set their Q values equal to each other. And whichever one is losing the energy, whichever one's temperature is decreasing is losing the energy, so its Q value is going to be negative. Whichever one is gaining the energy because its temperature is increasing is going to be a positive Q value.